Hi class, this is section 10.3, Applied Properties of Chords. We've already talked about what chords are. They are segments, line segments that have both endpoints on the outside of a circle. So the first part here says a diameter divides a circle into two semicircles. So if I draw a diameter in here, so there's a diameter, and our diameter really should not go outside of the circle, but it divides it into two semicircles. So on the top, right here in red, this red arc, that's a semicircle. And then along the bottom, this blue arc, that right there is another semicircle, or another half circle. And then any chord, it says, divides a circle into a minor arc and a major arc. So if I draw a chord in here, well, that now is going to split my circle into a minor arc, which I'll draw in blue here. That would be a minor arc, which we talked about in the last lesson. And then it also splits it into a major arc. So this over here would be my major arc. So theorem 10.3 says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So in my picture here, arc AB is congruent to arc CD if and only if, and that would be if and only if this segment is congruent to this segment. So segment AB, oops, I need my pen, segment AB is congruent to segment CD. So let's look at this example here. It says example 1. In the diagram, circle A is congruent to circle D, so we know they're congruent circles. If segment BC is congruent to segment EF, so that's marked, segment BC is congruent to segment EF, and the measure of segment EF is 125 degrees, so that's drawn on here as well. That arc, or the measure of arc EF is 125. Find the measure of arc BC. Well, because of this theorem we just talked about here, since these two chords are congruent, these two arcs are going to be congruent as well. So this, the measure of arc BC, is also going to be 125 degrees. On your own, it says if the measure of arc TV is 121 degrees, so I know this is 121 degrees, find the measure of arc RS. Well, since I know these two chords are congruent, because it both says they're both 6, I know my arcs are congruent, so it's 121 degrees. We've got two more theorems here. Theorem 10.4 says if one chord is a perpendicular bisector of another chord, so here's a chord that it's perpendicular and it bisects this chord, then this first chord is a diameter. So if we know we've got a chord that bisects another chord perpendicularly and it cuts it in half, that's what bisect means, we know this one has to be a diameter. So if segment QS is a perpendicular bisector of segment TR, then we know that segment QS is a diameter of the circle. Theorem 10.5 says if a diameter of a circle is perpendicular to a chord, so we've got a diameter and it's perpendicular, then the diameter bisects the chord and its arc. So this cuts this chord in half, these two pieces are congruent, and it cuts this arc in half as well. These two sides of the arc are congruent as well. So if segment EG is a diameter and segment EG is perpendicular to segment DF, then segment HD is congruent to segment HF. I just pointed that out. These two pieces are the same. And we also know these arcs are congruent as well. So we can say arc GD is congruent to arc GF. Let's look at the next page. So example 2, we're going to use those two pieces that we just learned. It says use the diagram of circle E to find the length of segment BD. Well, looking here, I know this is perpendicular and it goes through the middle. So since this is a diameter and it's perpendicular to this chord, it cuts this chord in half. So if this is 6, this top piece must also be 6. So if I want segment BD, that's this entire segment, so it's going to be 6 plus 6, which equals 12. On your own too, it says find the measures of arc CB, arc BE, and arc CE. Well, looking at my picture here, I know this is the diameter, and it cuts this chord perpendicularly. It's at a perpendicular angle. So these two pieces are the same, and these two pieces are the same. So since these two arcs are congruent, I can set those two expressions equal to each other. I can say 4x equals 80 minus x. If I add x to both sides to solve this, I have 5x equals 80. Divide them both by 5, and x equals 16. So this is 80 minus 16, and this one is 4 times 16. 4 times 16 is going to be 64 degrees, and then 80 minus 16 is also 64 degrees, which those better be the same. So those are both 64 degrees. So the measure of arc CB is 64 degrees. Keep writing an extra 0 instead of the degree sign. The measure of arc BE is also 64 degrees. And the measure of arc CE, well, that's going to be those two arcs added together. So 64 degrees plus 64 degrees, which would be 128 degrees. Okay, theorem 10.6 says, in the same circle, or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So we know the chords are the same if they're equal distances from the center. So this says segment AB is congruent to segment CD if and only if, and that would mean if and only if these two little pieces are congruent. So we can write EF, and we're just going to write capital E, capital F, because that means the distance from E to F, is equal to capital E, capital G, so the distance from E to G. Example 3 here, it says in the diagram, AB equals CD, which equals 12. So the distance of AB and the distance of CD are both 12, or the length of them, so that means they are the same distance from the middle, so I can mark those two pieces the same. Find EF. Well, I can write an equation here. I can say 7x minus 8 equals 3x. Solving this, I will subtract 3x from both sides to move my x's to the same side, and then add 8 to move my 8 over here. So I have 4x equals 8. Dividing them both by 4, I find that x equals 2. But EF here, that's the distance I want to find, that's 3x. So that's 3 times 2. So I know that EF equals 6. And there's my answer. The next one here. It says in the diagram, the two chords are equidistant from the center. So these are the equal distances. So we know that these two amounts are also congruent. Find the length of the chords. Well, let's set our equations, our expressions equal. 6x minus 5 equals 13 plus 4x. Solve them both. Subtract 4x from both sides. Add 2x minus 5 equals 13. Add 5 to both. So 2x equals 18. Divide them both by 2, and x equals 9. But if we want the length of each chord, we're going to have to substitute 9 into both sides. So this is 6 times 9 minus 5. And this is 13 plus 4 times 9. And those better be the same because they're supposed to be. And if you put this into your calculator, you'll find this is 49 and this is also 49. So the length of the chords is 49. Please make sure if you have any questions, you ask me about them, and have a great day.